right, so I have these three number lines here, right? They all have a length of 2, right? So we know that much. This first one here, it's broken into fourths, okay? So we're going to label it in fourths, all right? This may seem silly, but just trust me, bear with me. So this is 0. That makes this 1/4. That makes this 2/4. That makes this 3/4. 4/4. 5/4. Oh my God, I did that last period too. Thank you for catching it. They were laughing when I was done. I was like, why is this so funny? It's because I'm a moron. Okay, thank you. 4/4. I think I was already thinking about this one. All right, 4/4, 5/4. Let's make sure I get the rest of this. 6/4, 7/4. And thanks for correcting me, not just sitting there laughing at me. And 8/4. Okay, so we counted in fourths. That makes sense? That's what I mean by counting fractionally. We know they're fourths. It's how many fourths we have. Now, do all of these numbers are they all in the best form they could be in? No. So even as we're counting, we can say, okay, 0, 1/4, 2/4, which I know is 1/2. Then 3/4, 4/4, which I know is 1. 5/4, 6/4, which I know is 3/2. 7/4, 8/4, which I know is 2. Okay? So we're going to have to be able to count forwards and backwards. So if I didn't have anything on here labeled, okay, so let's just pretend like there's nothing on there, but I know I'm counting in fourths. I want to know what this is. I know I end here at 2, which in terms of fourths is 8/4. So I back up 1. When I back up 1, I'm at 7/4. Okay, does that make sense? All right, so it's like getting a common denominator, but without actually having to do that or thinking that way. Okay, it makes it a lot simpler. I promise you all this will be no big deal in the end. We just got to get through it. Okay, so then this one is broken into thirds. So I have 0, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Okay, so that's how I can count in thirds. If I want to know what this is, I know that this is 6/3. Back up 1, I'm at 5/3. Even though 6/3 will really be represented as 2, right? But it's 2. But if I'm thinking in terms of thirds, it's 6/3. And then this, of course, would be 1. Right? Make sense? Okay, so sometimes we need to think just purely in a little, all in fourths or all in thirds or whatever, but then we can also put it all together. So if I know this has a length of 2, I know I start at 0, I know I end at 2. So halfway in between the 2 is 1, right? Hopefully that makes sense. Halfway between these two is 1/2. So 1/2 is right here, okay? So that our brains don't explode with fractions, we can think fractionally to get to the other one. This is 1/2. This is 2/2, which is 1, which means this is 3/2, and then we have 2. Okay, make sense? Halfway between 0 and 1/2 is 1/4. So I have 0, I have 1/4, 2/4, which is 1/2, right? Then 3/4, then 4/4, which is 1, and then 5/4, 6/4, which is 3/2, 7/4, and then 8/4, which is 2. Okay? Make sense? That's what I mean by counting fractionally. I think this will also help with you understanding what I mean by what I'm saying here. All right, so then my thirds. This is 1/3. So this is another third, this length. So 1/3. This is 2/3. This is 3/3, which is 1. Then this is another third, so that's 4/3. Then another third, 5/3. Then another third, and that's 6/3, which is 2. Okay? So do you understand the counting fractionally? Just because it's fractions doesn't mean it's crazy hard or crazy weird. It's just how many things do you have, basically. Okay? We good? All right, so then I took this number line, okay, and I wrapped it into a circle, which means the circumference of this circle is 2. Right? Because there's where my number line started, wrapped it all the way around. So we start at 0, we end at 2. We good? So halfway around the circle then would be 1. We agree with that? Halfway between 0 and 1 is 1/2. So this is 1/2, 1. Oh, sorry. 1/2, 2. 2/2. Bless you. That makes this 3/2. Which makes this 4/2, which is 2. Halfway between 1/2 and 0 is 1/4. So I'm going to count fractionally. I have 1/4, 2/4, that makes this 3/4, makes this 4/4, 5/4, 6/4, which is 3/2, and then 7/4, and then 8/4, right? Because we had it. Same thing as the number line, we're just going in a circle. That's all it is. All right, so then my thirds. This is 1/3 right here. I go another third, so this is 2/3. This is 3/3, which is 1. Here's another third, so this is 4/3. Another third is 5/3. And then another third is 6/3, which is 2. Right? So then we have one more marking on here that we didn't have on our number line. And this right here, it's halfway between 0 and 1/3. What's half of 1/3? A 6. So this is 1/6. So let's count in sixths. This is 1/6, 2/6, which is 1/3, 3/6, which is 1/2, 4/6, which is 2/3. This is 5/6, which is 5/6, 6/6, which is 1, 7/6, 8/6, which is 4/3, 9/6, which is 3/2, 10/6, which is 5/3, 11/6, and then 12/6, which is 2. Okay? Does that make sense? We good on that? So if we can count fractionally and you understand what I mean by that, then I think that might help as we progress forward. All right? We all good? Okay, good deal. So let's look at your notes. These are going on page 72. 72 when we're done. All right, so we're going to look at angles in the coordinate plane, which may or may not be new to you. I'm not real sure, but I'm going to teach it to you like it's new to you. So we can have angles in our coordinate plane. They can be anywhere, but what we're mainly concerned with, for the most part, are the ones in standard form. Excuse me. So an angle on the coordinate plane in standard form, when the vertex is on the origin, so here's my vertex on the origin right there, and one ray lies on the positive x-axis, which means we always start here. That's why I started with 0 where I did on that circle, okay, instead of starting anywhere else. All right, so this ray that lies on the x-axis is called the initial ray, the initial side. We'll say initial side. So then the angle opens up. The other ray is called the terminal side. So the initial side is where we start. The terminal side is where we end. Okay. So in this one, you can see this arrow. It shows that we start here at 0. We open up this way to get our theta. That is a counterclockwise rotation. A counterclockwise rotation results in positive angle measures. If you go clockwise, you end up with negative angle measures. And hopefully in geometry you did talk about the fact that you can get negative angle measures. When you're just drawing a triangle and, solving for a side or whatever, you're not going to have a negative angle measure in that, but you can on the coordinate plane. Okay? Everybody good with me so far? All right. So angles are not new to you. Degrees are not new to you. The most common measure for angles is the degree. Been dealing with degrees for a long, long time. How many degrees are in a full rotation of a circle? 360. Okay, so a degree, 1 degree, is equivalent to 1/360th of a full rotation. All right, so now we're going to sketch them in standard form. We're not getting out protractors and making them perfect, but they should be pretty close to, it should be obvious you're aiming for the right numbers and not just randomly putting things somewhere. So we're going to start with 135 degrees. So we know we start here. This is 0. Okay. Then this is 0 and this is positive, so we're going to go this way. I know that all the way around is 360. How much is this if I go to here? 180, this is 90. So I know that I'm not going to 180, I'm going to 90 plus some more. So I subtract 90, and what do I get? 45. So if each one of these quadrants is 90 degrees, 45 is halfway. So I go 90 and then another 1/2 like that. Okay? That in itself is not enough because we don't know which way we opened up. That's why you have to have this saying, okay, I started here and I went to here, and that is 135 degrees. Everybody okay with that? So our next angle is 495 degrees. So you might not have known that you could have an angle that big, or that's like bigger than 180. Again, that's not going to be inside of a triangle, but it is going to have applications in other things. So I know I start here, and I know if I go all the way around, it's 360, right? So I'm going to subtract 360 from this. What's 495 minus 360? 135. Do you know where 135 is? Yeah, we just did it, right? So this is what 135 looks like. Oops. And again, we need to look like we're aiming for halfway. But these are not the exact same angle, and that's why that arc is so important. Because what happened was we started here, we did a full rotation, and then we ended here, and that is 495 degrees. Okay, make sense? We good? All right, so then I have a negative angle, which means I still start here, but I'm going to go clockwise instead. So I know if I go to here, I go 90. How much farther than 90 do I have to go? What's 140 minus 90? 50. So I go 90 and then another 50, which is just a tiny bit past halfway like this, and then I show that I went negative like that, and so that's negative 140 degrees. One of the things that we have to make sure that we know and understand and don't get wrong is where our quadrants are in our coordinate plane. Okay, your quadrants, if you recall, go 1, 2, 3, 4. And if you're like me, when I first learned that, I thought to myself, that's really stupid that they numbered them that way, because we read left, like 1, 2, 3, 4 would make way more sense to me. But now you can see why it is that, because we start at 0 here and we open up this way and it rotates. That's why your quadrant numbers rotate like that. Okay, we good? What questions you got? All right, so another something that you did in geometry was learn about radians. Our life is about to become 95% radians, 5% degrees probably. And you will learn to love radians way more than degrees. You probably won't believe me today, but you will eventually believe me, okay? I promise you that. So a radian. A radian is a unit of angle measure based on arc length. Okay, so 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So that means this is my radius. If I take that, just like I took that number line, and I bend it around here, that's 1 radian. So no matter what this is, like if this was 5 centimeters, this is 5 centimeters, but it's 1 radian. So a radian is based on length instead of based on curvature like angles are. Okay, so I have a quick little video to show you that might do a better job than me. Let's see. Okay, whatever. Here we go.
We start with a circle of radius r. We take that radius distance and wrap it around the circle. The angle formed by that radius distance is 1 radian. Since the circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle. So halfway around the circle, we would expect 1 pi radian, and around the entire circle, we would expect 2 pi radians.
Okay, so we have 360 degrees. We start from here and go all the way around, but we also have 2 pi radians. They're the same thing. It's just like inches and centimeters. It's just a different type of measurement. All right, so if this all the way around is 2 pi radians, halfway around is pi, right? So that's what this says here. So it says recall, because it's something we should know, recall that the circumference of a circle is 2 pi r. So 360 degrees is the same as 2 pi radians. Now, although when we have degrees, you always have to put the degree sign, with radians, you usually don't use the units on there. I know that's kind of weird. We'll talk about why a little bit later, but past this, I probably won't write that. So if 360 degrees is 2 pi radians, then 180 degrees has to be pi radians. Right? So I need to be able to convert from degrees to radians. This is something you need to know how to do that we're going to do a little bit of, but again, that's not the main focus of what we're doing, so we'll do it a little bit so you understand what's happening, and then we're just going to live in radians for the most part. So if I want radians, I take my degrees and I multiply it by pi over 180 because it's just a proportional relationship. If I want degrees, I take my radians and multiply it by 180 over pi. So it's either pi over 180 or 180 over pi. So you ask yourself, if I want radians, I want to put the pi in it, so the pi goes in the numerator. If I want degrees, I want the pi out of it, so it goes in the denominator. It's not that hard to keep it straight. Okay? And then, so it says to convert each angle and state the quadrant. So we're actually going to state the quadrant first. So I'm going to draw a tiny little x and y axis here. So 60 degrees. If I start here, 60 degrees is going to be in what quadrant? 1. It's like 2/3 of the way, right? So we're in quadrant 1, so we can answer that part. I want to convert from degrees to radians, so I'm going to multiply by pi over 180. I can divide those both by 10, so that'll leave me 6 over 18, which is 1/3, right? So I get pi thirds. We would never write 1/3 pi. It is pi thirds. Okay. Questions? All right, so on number 5, we have 160 degrees. What quadrant will that land me in? 2, because I'm not all the way at 180, right? I'm at 160. So this is in quadrant 2. So I multiply by pi over 180 and divide them both by 10. So then I have 16 and 18. That'll give me 8 pi over 9. Any questions? All right, so then I have negative 330. What quadrant do you think negative 330 would land you in? I heard 1. Do you agree with that? 1 because it's negative, right? So negative, almost a 360, but not quite, so I am in quadrant 1. Very good. It's in quadrant 1. So I'm going to multiply by pi over 180. I can divide them both by 10. Then I can divide them both by 11, so that's going to be both by 3. Negative 11 pi over 6. What questions do you have? All right, so now we're going to convert from radians to degrees. I am well aware of the fact that you're not very comfortable with radians right now. However, I'm going to push you out of your comfort zone, and we're going to figure out the quadrants before we convert. Then after we convert, it'll be in degrees, and then we can see if we're right or not, okay? And that's the way I want you to practice it as well. So we're going to think about, and you might want to draw this. So we have this little, we know that this is 0. We know all the way around is 2 pi. We know that halfway is pi, right? So at 90 degrees, that's going to be pi over 2, which is pi halves, right? So if we count in halves, this will be pi halves, 2 pi halves, which is pi, 3 pi halves, and then 4 pi halves, which is 2 pi. Okay, does that make sense? That's how we count in halves. All right, so now we're going to convert into, we're going to do the quadrants first. So we're going to think in terms of 18ths. So this is 1, right? So this is 18 pi over 18. Would you agree with that? Which means this is 9 pi over 18. If this is 9 pi over 18, what quadrant is 5 pi over 18 in? 1. See how that works? Okay, so I'm in quadrant 1. And then again, we're going to convert, and then we can double check that we were right. So now I want to get it into degrees, so I'm going to multiply it by 180 over pi. The pi's cancel out. 18 goes into 180 10 times. So I get 50 degrees, which is, yes, definitely in quadrant 1. Okay, we good? Any questions? All right, so then I have negative 11 pi ninths. So I know I'm going to have to go clockwise. At 1, I'm at 9 pi ninths. If this is 9 pi ninths, what quadrant is negative 11 pi ninths in? 2, right? Because this, I'd have to go another 4.5 to get all the way here. So I'm in quadrant 2 here. So then I'm going to multiply by 180 over pi. The pi's cancel out. 9 goes into 180 20 times. So I get negative 220 degrees. Is it hot in here, Dale? Okay, I'm sitting here sweating. I didn't do that much. All right, 7 pi thirds. All right, so I'm here. This is 3 pi thirds. All the way around is 6 pi thirds. If I back up 1, I'm at 5 pi thirds, right? But if I go forward 1, I'm at 7 pi thirds. So that puts me in the first quadrant. So I'm going to multiply by 180 over pi. The pi's cancel out. 3 goes into 180 60 times, so I get 420 degrees. What questions do you have? Okay, we good? All right. Okay, so now we're going to talk about coterminal angles. The prefix co means together. Terminal is like to terminate or end, so it ends together. Coterminal angles end in the same spot. They start at the same spot and they end at the same spot. They didn't necessarily go the same way to get there. So if we start here at 0, I can go 90 degrees this way, or I can go a negative 270 this way, and we would both end up at the same spot. Does that make sense? So 90 and negative 270, coterminal angles, because they're totally different angles, but they end in the same place because we're going in circles, right? So all we have to do to get this, if I'm here at 90 and I want to figure out what the other one is, all I'm going to have to do is subtract 360 because it's just one rotation. I'm either going to add 360 or I'm going to subtract 360. So it says find an angle theta coterminal to the given angle where theta is between 0 and 360 or between 0 and that should actually say 2 pi and not pi. So if I get to 5, let's just say 544 is right here, okay? Another rotation would get me in the same place, but I don't want to add 360 to it because I need it to be between 0 and 360, so I need to subtract 360. And what's 544 minus 360? $184, yeah, 184 degrees. All right, so then if I'm at negative 170, which would be like right here, okay, I need another way, like I can add 360 or I can subtract 360, but because I want my answer to be between 0 and 360, I'm not going to subtract 360. I'm going to add 360, which is really like subtracting here, and we get that theta is 190 degrees. Okay, that makes sense? All right. So 11 pi halves, same thing. Wherever 11 pi halves is, let's say it's here, okay? 11 pi halves, I'm either going to have to add or subtract a full rotation, which is 2 pi. But this is in halves, so I need to think fractionally. I need to think in terms of halves. So 2 pi is the same as 4 pi halves, yes? So that means here I don't want to add because it's got to be between 0 and 2 pi. That's definitely more than 2 pi. So I'm going to subtract 4 pi halves, because that is 2 pi. And that's going to leave me with 7 pi halves. Is 7 pi halves between 0 and 2 pi? No, because 7 over 2 is 3.5, right? So that means I have to subtract another rotation. I subtract 4 pi halves again. And that's going to give me 3 pi halves. Is 3 pi halves between 0 and 2 pi? Yes, so that is my answer. My negative 5 pi halves, I'm going to have to add to that. So again, I'm in pi halves, so I'm going to add 4 pi halves. That's going to give me negative pi halves. That's still not between 0 and 2 pi, so I'm going to add 4 pi halves again, and that gives me that theta is 3 pi halves. Okay. So, since I got the same answer, here's what this tells me. That 11 pi halves, 7 pi halves, 3 pi halves, negative 5 pi halves, and negative pi halves are all coterminal angles. They're all different numbers, and they're all different ways to get there, but we'd all land in the same spot. Okay, we good? It depends on how many times you run around the track is what's happening. Any questions? All right. So we're not doing that part. Okay, reference angles. Reference angles are going to become hugely important to us because we have to know a whole lot of things about a whole lot of things. But if we know what we need to know about what our specific reference angles are, and we'll talk about what those specifically are, then that's going to apply to every angle that uses it as a reference angle. Okay, that's why it's important to understand what they are and how to find them. Okay, and so what they are is, so for an angle theta, and it has to be in standard form, the reference angle is the positive acute angle, this should say formed, not formed, formed by the terminal side and the x-axis, not the y-axis, the x-axis. It is the shortest way back to the x-axis. So I have this angle here, theta. So once I get theta here, the shortest way from the terminal side back to the x-axis is this way. That's my reference angle. So your reference angle is not necessarily in standard position. That's okay. Theta has to be, but the reference angle, and it doesn't matter which direction you go, it's always positive because it's just the measure. It's not telling you direction. Okay? So let's look at this 150-degree angle. In order for me to sketch this, I'm going to start here. And then I'm going to open up this way. So I'm going to have to go 90, and then how much more? Whew, what's 150 minus 90? 60. Whew. All right, so 60 is 2/3 of the way to 90. So it would look something like this. So that's what this makes 150 degrees. Okay, so that's my angle. The reference angle is the shortest way back to the x-axis. It's this angle right here. And what's that measure? 30, because it's another 30 degrees. Your reference angle is 30 for 150. Okay. Everybody good with that? All right, so then we have 315. So I start here. This is 90, 180. How much is this? 270. And then I got to go some more. So what's 315 minus 270? 45. So this right here is my 315-degree angle. The shortest way to the x-axis is this right here. And what's that measure? 45. Well, if this was 45, that has to be 45, right? 45 degrees. That's your reference angle. Because another way to graph that 315 is to think, okay, well, if I go 360, I can back up 45, and that'll put me at 315. That's another way that because we need to be able to think forwards and backwards with this stuff. Okay, everybody good with that? All right. So then negative 240. So I start here. I'm going to go negative 90, negative 180, and then how much more? What is 240 minus 180? 60, thank you. So go another 60. It's like 2/3 of the way. So this is negative 240 degrees. My reference angle is always the shortest way back to the x-axis. It is this right here. Okay? And what does that measure? 60, because we already figured out, right? We said we had to go 180 to another 60. That makes this 60. So my reference angle is 60. What questions we got? All right. So we're going to do the same thing with radians. And I'm going to give you some basic angles that we need to know. So we should know now, of course, that 0 is 0. Pi sixths is 30 degrees. Pi fourths is 45 degrees. pi thirds is 60 degrees. Okay, those are our special angles, like we talked about special right triangles yesterday. Those things right there, you definitely need to commit to memory like now, right? And we can always look at the circle again to figure out, how to get there. We'll look at that too. But all right, so let's graph this 5 pi thirds and find its reference angle. So I start here. We think in terms of thirds, right? So I'm going to go here. This is pi, so this is 3 pi thirds. All the way around is 6 pi thirds. So what do I need to do? Back up one, right? I back up pi thirds. Pi thirds is 60 degrees, so I end up like right here. So this is 5 pi thirds. Everybody understand how we did that? I know radians are new to you, but I want you need to start thinking this way and trying to figure it out. All right, and so that means that my reference angle here is what? Pi thirds, because we backed up pi thirds, right? Everybody good with that? Ask me questions if you got questions. Okay, start at 0. We're thinking in terms of sixths. So this is 6 pi sixths. This is 12 pi sixths. If I back up one, I'm at 11 pi sixths, but I want to go to 13 pi sixths, so I go forward one. Pi sixths is 30, so I'm about right here. So means I started here, went all the way around like this. That is 13 pi sixths. So what is my reference angle? Pi sixths. Okay. What questions do you have? All right. So then I have negative 5 pi fourths. So I'm here at 0. I'm going negative, so I have to go clockwise. So I go to 1, that's 4 pi fourths. Then I have to go forward one more to get to 5 pi fourths. That's 45, so we're right here. So this is negative 5 pi fourths, which means your reference angle is what? Pi fourths. All right, so I want you to look at this. 5 pi thirds, my reference angle is pi thirds. 13 pi sixths, my reference angle is pi sixths. 5 pi fourths, my reference angle is pi fourths. You see a connection there? So we're going to talk about our pi thirds angles, our pi fourths angles, our pi sixth angles. And if I know everything I need to know about pi thirds, I also know everything I need to know about 5 pi thirds and 2 pi thirds and all the rest of that stuff with just a little tweaking. All right? Now look at that compared to the angles. Do you see a pattern with the angle measures? Not so much. Like you have to know where you are and which way to go to subtract, and it's way more complicated and there's a whole lot more numbers going on. I promise you, radians are going to make your life a ton easier. Plus, you don't really have a choice because that's where we're going with it. But you just need to embrace it because it really is way easier to deal with, I promise. Okay? I know you still may not believe me right now, and that's okay. All right. Any questions at this point? All right, so let's talk about quadrantal angles, because I had this question yesterday. Some of you may be thinking it, but nobody asked me yet. When we were talking about what quadrant we're in, what if it lands on the axis? Like, what if I'm at 0, or I rotate around and I end here? I'm not in a quadrant, I'm between quadrants, right? So those angles are called quadrantal. So it says when the terminal side of an angle, theta, in standard position, that's important, lies on the x or y axis, it's called a quadrantal angle. So you have to not only say that it's a quadrantal, but you also have to say where it landed, okay? So if I land here, whether it's 0 or it's 2 pi or it's 4 pi or 6 pi or whatever, if I land here, and I say what quadrant are we in? We're not. It's quadrantal, and we landed on the positive x-axis. If you land at 90 or pi halves or 5 pi halves or 9 pi halves or whatever else lands you there, then you say this is quadrantal, and we have the positive y-axis. That's where we landed. If you land at 180 or pi, or 3 pi or 5 pi or whatever else is going to get you there, negative pi, then we say it is quadrantal. And this is on the negative x-axis. I know it's a lot of writing right now, but basically get over it. But also you can't really abbreviate it because then what are you trying to say? Quadrant, quadrilateral, quadratic? Like you can't really abbreviate it. And then if you land at 270 or 3 pi halves or 7 pi halves or whatever, then it's quadrantal. And it's on the negative y-axis. Okay. What questions do you have? We good? Okay. I highly, highly, highly encourage you to actually get your Delta Math done before tomorrow so that the activity that we do tomorrow will make a little bit more sense to you and all this has sunk in some before we move forward. Okay? Are we good? All right. Your assignment's in Delta Math.